The 5-figure numbers are to be formed from the digits 1, 2, 3, 4, 5, 6. How many 5-figure numbers can be formed if the repetition of the digits allowed? So if you just look at very quickly, it's actually a very simple problem. You have 1, 2, 3, 4, 5, 6. You are to take. Right? You can look at it as maybe just a slotting method. You go to the first one, and I think to myself, how many choices can I put here? Simply, you can see that I can put 6. Right? There are 6 choices. I go to the second one, and I think again, how many choices can I put? So most of the time, if you all get this question wrong, it's because maybe you didn't read the question carefully. You didn't know that you can repeat. So you are thinking whether it's replacement or not replacement. Are you thinking about arrangement or not arrangement? But here, key thing is that the repetition of the digit is allowed. So because repetition of the digit is allowed, right? That means over here, no matter what I choose, even if I have to choose maybe number 1 here I can choose 1 again. So that means, right, if you think from the slot point of view, at every slot, at every number, I always have 6 numbers to choose from. 1, 2, 3, 4, 5, 6. Third number, I have 6 slots to choose from. Fourth number, 6 slots. Fifth number, 6 slots. So the total number is actually just 6 to the power of 5, which is 7, 7, 7, 6. Alright, that is the number of 5-figure. Okay, can okay, then next one, part 2. Okay, if I want each digit to appear at least twice, I want every digit in the number to appear at least twice. Think carefully. Okay, so a lot of times people may miss out certain cases, so you really need to really put down your thought and think. So if you cannot, a lot of my students, a lot of you who don't know how to do, what I do is I just tell you, just write out some numbers. So some of you all started writing this, like maybe 1, 1, 1, then you wrote 2, 3, 4. Some of you actually wrote this. So then I ask you, is this every digit appear twice? No, actually it's not. So you say, it's not, no. This 2, 3 digits doesn't appear twice. So when we want, then you cancel this and you start to think, maybe it could be 1, 1, 2, 2, 2. Write 5 digits. Yeah, after I told you, write some more, write a few more cases, and then you start to write this 1, 1, 1, 1, 1. Then you think. After that, I ask you, any more? And then you can realize that actually this is about the only 2 cases that you have. So with these 2, right, if you don't know how to solve a question, maybe just start from somewhere, just write an example, and then from the example, try to think about whether is it possible to find other cases. So the first case, this really means that, if I were to think about this, right, I can have 1 digit that appears maybe twice, another digit that appears 3 times. Alright, and simply, how many ways can I choose the second digit? So this is not 6 choose 2, remember. 6 choose 2 is only if both the digits are repeated like the same number of times. So this is, for example, first one, this will be 6 choose 1. After which, you go to the second digit, this will be 5 choose 1. Right, so maybe instead of using this notation, let me write 6 choose 1. And then after which, so a lot of times I told you, you choose first, then you arrange. Right, why are we arranging here? Because does the order matter? So you ask yourself, the order matter. So a lot of times I told you, you can select first, then you arrange. You consider the number of cases. You look at it, whether it's possible to think from the slot point of view or the human point of view. And then look at it, you know that it can be actually arranged in 5 factorial over 3 factorial, 2 factorial ways. And the answer will just be 300. This is for the first case. So the second case, right, remember if you want to repeat at least twice, you can actually have 1 digit repeating by itself 5 times. Right, so the digit is repeating by itself 5 times. Then what are we doing? Basically, again, I told you, choose first, then you select. Then you choose first, then you arrange. So I do a 6 choose 1. Out of 6 digits, 1, 2, 3, 4, 5, 6, I choose 1 to repeat 6 times. And I ask myself, is there any way I can rearrange this? Well, it's just like 6 factorial over 6 factorial, because the 5 factorial over 5 factorial, because the digits are all the same. So there's only just answer is just 6, right? Because the arrangement doesn't matter, every digit is the same. And so your final answer for part 2 will just be 300 plus 6 to be equal to 306. So this will be the total number of 5-figure numbers.